Everyone, welcome to 7.3, question 7. So in this case, we have a company that's paying out a dividend with a 3% increase each year. So it looks like we have a growth dividend payout. Last year, we have a most recent dividend of $1 per share, and we need to figure out what the rate of return of a 15% stock based off of it looks like a finite number of years from A to E. And then finally, we're going to be dealing with the infinite or the forever case. So let's go ahead and get our table ready here. Okay. And what do we know? Well, we know the rate. Okay, it's 15%, and that's true in all cases. Our growth, okay, our G is again going to be a 3% increase, and that is also true in all parts of the question. Now, dividend or most recent dividend has also been given to us. Okay, so that's that dividend 0. So it's a $1 dividend, and that is true in all cases. What will change is the number of periods. Okay, so company or part A, the company is existing for 5 years. Let's make sure we have the right format here. Then part B, we're going to see what the value is for 15 year, 25, 35, and then finally we have forever. Let's write forever this time. Infinity or forever. It's a little more romantic. Okay, and what we need to figure out ultimately, obviously, is we always need to figure out the price. But let's talk about this in just a moment. So reminder, okay, so when we're dealing with part A to part E, okay, we're going to be looking or using the constant growth model that's finite, okay? So if that's the case, then we need to use the following equation. Okay? So now I want to break down this equation a little bit just because first I just don't want to get boggled down by the math. But also hopefully it will illustrate something a little different that we haven't seen before, okay? And it might reinforce something we've been discussing as well. So ultimately, again, this first part, okay, which looks very similar, which actually is similar to Gordon's equation, okay? And we just have to account for that time difference, okay? So it's no longer finite, so this is going to help us recognize what happens when we're dealing with a certain finite number of periods, okay? And then ultimately that's going to give us our price. So actually let's make some room here. Okay, so this gives us our price 0, okay, starting price. So let's start with A to E, okay, and we'll talk a little bit about what happens when things happen forever, okay, in terms of the company lasting forever. So again, I'm just going to do this first part, then we're going to get the product of the second part of the equation, okay, so let's do the math here. So our dividend, okay, that $1 multiplied by 1 plus G, okay. So our G, again, our growth percent, our growth rate, because it is decimal form. Then we're going to divide that by R minus G. Okay, 5.85, okay. Now, we're going to bring this all the way down, actually. And at first, you might think, oh, goodness, why is it all the same? I did something wrong. But then you'll realize that it is the same if we're just dealing with, not dealing with any growth periods. okay? So we're not dealing with any numbers or period or time horizon. So if this is true forever, in other words, the price will be the same, okay? Just like we did in the previous example, okay, with the Gordon model, same idea, okay? So the value or the price will be the same if we don't account for the number of years. However, we're accounting for the number of years, so we have to remember we're going to be multiplying by that other part of the equation here. So let's go ahead and do that, okay? And then maybe we can see some interesting things that are happening. So let's get the formula. 1 minus 1 plus g. Okay, we're going to divide that by 1 plus the rate. And then we're going to raise that to the power of our number of periods. Okay. Let's just keep this general for now. Okay. So, in other words, it's basically what this is sort of a percent of what we'll get. So if this company only lasts for 5 years, then we're going to get less than the price if it lasted forever. Okay, think of it that way. Okay, and we'll talk about what happens here. So now we can actually go ahead and get the full value. Okay, so that's simply going to be the product within this equation. Okay, so we're multiplying these two. Okay, and again, let's take a look at our pricing. Okay, so if we look at A specifically, okay, so we can see that, or we can compare A and B. So the company is only lasting for 5 years. Okay, so the price is going to be less. Okay, but as the company lasts for a longer period of time, then that value or the price or the present value of that company or the price of that stock increases. Okay, now look what's happening here. Now we shouldn't be technically using the same formula. If you recall, what should we be using? Well, remember it's the constant growth with an infinite, okay? So again, if we want to be very precise here, so that is simply for f, okay? So we use this for f because it's forever, so it's infinite versus the finite that's from A to E. Okay, now if you recall, Gordon's model will look very similar to the part. So again, with Gordon's model, it doesn't take into consideration the number of years, okay? So ultimately, now I said forever here, okay? But if you think about it, basically what that means is it's just the 8.58, okay? And really, if you look at this, technically, if this gets, the higher the number of years, okay, because it's, well, let's talk about it for a moment, okay? So remember, R minus G. So we know that R is greater than G, correct? Okay, so if R is greater than G, then that means that the denominator will always be bigger than the numerator. So what that means is that anything to the power, when you have the denominator greater than the numerator and we're raising it to the power, then ultimately this number gets really, 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 really small. The more periods it gets, okay? So what does that mean? Well, 1 minus something that's really, really, really small gets to the point where it's just 1 minus nothing, which just means it's times 1. So ultimately, and if we want to be, let's say we made this a billion, million, who knows what this is, okay? Ultimately, this is going to become 1, right? In other words, this will be irrelevant because it's just going to be, it's times 1, right? And what we're left with is this equation here. So that's why the 0.58, or the price is similar when it's over 75 years or, billions, or forever, okay? Very, very close, you can see here. So that's how we can answer the forever part. We just have to use the first part of this equation. But what's important to recognize, and this is why we get to break it down, is the number of years makes a huge difference. And the shorter period of time means that we get less value out of it. Whereas eventually what when we get to closer to forever, what that basically means is that we have a higher percentage of the total value of that company. Okay, so of course we can plug this in and we'll get some very excellent words of encouragement, but we can do that on our own. So thanks for watching and happy financing.